All right, so now we're going to look at the diagonals of a rhombus. So a rhombus is like a diamond shape. A square is actually a rhombus. Not all rhombi are square, though. As you can see, this is definitely not a square, but all squares are rhombi. So a rhombus is a parallelogram with all four sides congruent. So all four sides are congruent. The diagonal of a rhombus are perpendicular. So you can see they come together at a perpendicular angle here. The diagonals of a rhombus they also bisect the vertex angles. So that's another special quality here. They cut the angles in half. They bisect the angles. So we can use the triangle angle sum property, which states that the angles of triangles add up to 180. Okay, you can see I've crossed this off. I accidentally repeated the diagonals of a rhombus were perpendicular, but that should not be on your paper anymore. I should have fixed that. So for the rhombus below, find the measures of angle 1, angle 2, angle 3, and angle 4. So we're going to find all four angles with just one angle given to us. Technically, there's more than one angle given to us because we already know that the diagonals create a 90-degree angle, right? They are perpendicular to each other. So we're given more than one angle right off the bat. It's just not marked. You have to know that about a rhombus, okay? So because we know that the diagonals create 90-degree angles, we also know that alternate interior angles are congruent. We can immediately find the measure of angle 1 because the right kind of top side here is congruent to the left bottom side. Not congruent, sorry, parallel, which makes this a transversal. So this means that 56 and 1 are alternate interior angles. So angle 1 is 56 degrees. So I can immediately fill that one in. So now angles are congruent and cut angles in half. That's another thing that I know about rhombi. We just learned that, right? The diagonals actually cut the angle in half. So if this half is 56, this half is also 56. So angle 1 and angle 2 are both 56 degrees. So now we can use the triangle angle sum theorem, which remember means that the angles add up to 180 degrees to find the other missing angles here. And I say, let's zoom in a little bit just so we can see this a little nicer because it was kind of small. So now I can focus on this side here because I have 56 degrees and I have the 90 degrees. So I can use the triangle angle sum theorem to find out what this angle 4 is because I can go 90 plus 56 plus my question mark there, or I can say angle 4 equals 180 degrees. So 90 plus 56 is 146. And if I subtract 146 from both sides, I will get 34 degrees. So angle 4 is 34 degrees. All right, so we can see that marked here, right? I have my 34 degrees here, and you can see it marked on here. So now the only thing we have left to figure out is angle 3. So angle 3, if we remember, again, we're using that same thing we've already used up here. Alternate interior angles are congruent because now I have 3 and 4 on alternate sides of this transversal. And again, this top left is parallel to this bottom right. So those are alternate interior angles. So those are also congruent. So that's 34 degrees. So that is using the diagonals of a rhombus to find angle measures. I hope that helps, and I will see you in the next video.